Hi guys, and welcome back. We are continuing with our talk on reduction formulae. Here we're going to do the 180 plus theta reduction. Okay, so let us look at what we have currently here. I've got my triangle in the first quadrant. So what did we establish so far? This whole thing of reduction says, wait, instead of just bothering with big angles like 180 plus, I mean, in this case, our theta is 36.62. So instead of what is 180 plus 36.62? Well, that is 216.62. Now, instead of bothering with this big angles, 216 and all that, why can't I just work with an acute angle, an angle lesser than 90 degrees? That makes some work simple. Why? Because remember when we dealt with special angles, our special angles are between what? 0 and 90 degrees. So it's really easy to figure stuff out and to work things out very faster when we deal with special angles. That's what we established. So that is the whole idea. That's why we want to know how this reduction formula says. So when I'm working on a problem, like for example, I'm going to work on a problem here. What I'm going to do right now is to actually rotate again this entire triangle around a point. And in this case, my rotation, as I said, is going to be 180 plus theta. And to show that this is 180 plus theta, let me quickly remind you of how we label this on the Cartesian plane. Remember, there it is 90 degrees, and here it is what? 180 degrees. So coming down here, it means we are having 180 plus theta, okay? And what is our theta? Here is our theta, 36.62. Now, check what's gonna happen. If I measure this angle just to prove for you that this angle is exactly theta, I'm gonna measure this angle here and you will see there it is, there's the value, it is 36.62. Here it is. Of course, GeoGebra will use beta, because it doesn't want to make it the same as the one that I had, but I'll go ahead, rub this out or write just on top of it and say theta. So you can see I've moved 180 plus theta. This is my point, okay? What are my coordinates here? Once again, ladies and gents, -4 and -3. And there's my R, which we calculated to be 5. So it will remain positive because of the theorem of Pythagoras, okay? In case you forgot, R squared in any right angle triangle is x squared plus y squared. So let's write down those ratios once again. Remember my D here is 4 and 3, okay? So let's write down those ratios once again. Sine of theta is opposite, which is what? 3. So here's my theta, 3 over hypotenuse, which is 5, okay? Cosine of theta is adjacent, which is 4 over 5. And the tan of theta is what? What do we have here? Opposite, which is 4. No. Opposite is 3, sorry. Opposite is 3. So then I have 3 here because that's the y value, and that's 4. Guys, you can go ahead and even do the one for the reciprocals. We know that the reciprocal for sine is cosec, so cosec will just be the reverse of sine, which is 5 over 3. Sec is the reciprocal for cos, so it will just be the reverse of cos, which is 5 over 4. And the cotangent is the reciprocal for tan, so it will just be 4 over 3. Now, let us try and see what happens here. I'm going to write down the value, the ratios for this angle. So we are dealing with 180 plus theta. We have literally rotated this point 180 degrees plus theta, which is 216.62. So let's go ahead and figure out what sine 180 plus theta is. Okay. So we see at this point, after rotating 180 plus theta, the ratio will be, what is y? Y is -3, okay? And what is r? R is 5. Okay, but wait a minute. 3 over 5 is just sine theta. So that means this thing actually reduces to sine theta by what we have in the first quadrant. So if you want to write this as an acute angle, just got to put a negative and have a sine theta. Let's move on to the cosine of 180 plus theta. What is this? We know cosine is going to be the x value, which is minus 4, over the r value, which is 5. But hang on, 4 over 5 is cos in the first quadrant, so this means is minus cos of theta. Let us go ahead and figure out what the tangent is. 180 plus theta. What is that? Okay, we know it's going to be the x value over the y value. So the x value here is minus 4. Is that so? No, no, no. Excuse me. Yeah, the y value is actually minus 3. Okay, is minus 3, and the x value is minus 4. I should probably do that so that I also don't get lost. And this is just exactly 3 over 4. But we'll hang on, 3 over 4 is tan theta in the first quadrant, or in the acute case. So something quite interesting to note, folks, is that, wait, sine 180, well, in the case of 90, sine was actually changing to cosine, okay? Remember that? We had here sine 90 in the previous video plus theta. This was actually changing to not negative cos. This changed to cosine, okay? Cosine of theta. And the cosine of 90 plus theta previously changed to actually minus sine theta. So what's going on here? Okay. Here's some, I mean, yeah, exactly what's going on. Even here, look at what's happening. 180, it changes to minus sign. So where do all this negative stuff comes from? Well, I hope you have read my mind. And as I'm trying to read yours, guys, remember in our function, in the trig graphs, in the graphs, guys, actually sine is positive between 0 and 90 degrees. And that's why we had that as positive. But cos is actually negative between 90 and 180. And moreover, cos is also negative between 180 and 270. As a matter of fact, cos is only positive in the first and the fourth quadrant. And then what about sine? The same thing. Sine here sin gives us a negative, so this should not be surprising because sine is indeed negative in this quadrant. In case you've forgotten, remember, all students take care. Guys, if you missed out on the cast rule, please watch the grade 10 video where I introduced the cast rule. I will not really address it in this grade 11 level because I assume you know it. But if you don't know it, as I'm saying, go ahead, search or just follow on one of our playlists for grade 10 trigonometry and just look at the intro to cast rule. You will see where this comes from in case you wanna remind yourself. Okay, so only all in the first quadrant, all the ratios are positive. Here only sine and its reciprocal, here only tan and its reciprocal, and finally here only cos and its reciprocal. So it is not surprising, it should not surprise us as a matter of fact that tan 180, the reduction tan 180 plus theta gave us a positive result here because that is what we have established previously using our graphs and studying the cast rule or the triangles in general, how they behave. So that's the news regarding the trig, the 180 reduction. As a summary, let's write that down. We just established that sine 180 plus theta is negative sine theta. We established if you had to reduce this, okay, you will just get the same answer saying minus cos of theta. Okay, this theta, by the way, this theta, that theta, The same thing here with tan of 180 plus theta is just tan theta. That's about it. Nothing fussy, nothing funny. That's all we did. Next video, we are discussing the reduction 180 minus theta. Please go ahead, try it. I'm not going to do the one for the reciprocals. That's your homework. You got to try and figure that one out. It's very simple. You know, you got to just got to swap the numbers around, okay, numerator and denominator, and you will be there, okay? So that's why I'm not really bothering much about it. So next up, we are discussing the 180 minus theta reduction. The idea is the same. So the next two sections, 180 minus, 360 plus, and 360 minus, we're going to have some fun because I trust that at this point, you now have an idea on how these things work. All right, I'll catch you later.